Hello everyone, my name is Dan Stoddard, and today we are going to learn about loops. So loops are a way to iterate through a block of code, or even just a line of code, multiple times. So if I wanted to print my name 63,925 times, or if I wanted to print all of the integers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to 357 million, there'd be a way to do that without me needing to write 357 million lines of code. And so that's kind of nice that we can go through that kind of procedurally and efficiently, not only for you, but also for the computer. And the way to do that is with loops. There's a couple of different types of loops, and so we're going to learn about what those types of loops are today. We're going to contrast them, and we're going to apply them to arrays if we have enough time to do so. So what we're going to do is we just have a beginning structure here. This is just a print statement. Hopefully you guys are familiar with this. So public class looper, that's the class declaration. Public static void main string args, that's going to be the method declaration. Public because any class can access it. Static because it doesn't require instantiation of a variable. Void because it doesn't return anything. Main because it's the name of the method. And string args because it technically accepts a string array. I didn't need to go through all that, but now you guys know. So system.out.println, yay, we get to learn about loops. And if I execute this piece of code, then there's a good chance that it would print, yay, we get to learn loops. So that's kind of nice. And so what I'm going to do is I'm going to modify this a little bit. And so I'm going to just let you guys know in a comment that we're going to do while loops, and then we're going to do for loops. And then if time permits, we're going to do either do while loops, or we're going to figure out how to apply these loops to arrays in particular. And I'll figure out which one would be more useful when we get there. So what I'm going to do is I'm going to start with int I equals 0. And the reason why I create that variable is because I want to keep track of how many times we run through a loop. Because I don't want to run through infinitely many times, but I certainly want to run through it a finite amount of times. So I'm going to start with int I equals 0. That's going to be what's called the counting index. And so what I'm going to do is I'm going to write the word while. Wow, that's the important word that makes everything come together. So I'm going to write while. Now that's a key word. That's why it shows up in purple. It's a special word that has a special meaning in Java. So I'm going to write while I is less than 4. So what does this do? This says, so while establishes it as a while loop. I is less than 4 is going to be a condition that checks to see if the variable I has a value that is less than 4. And if it does, then that means we're going to iterate through this code that I'm about to write. So if I was equal to 7, then none of this while, then it would still check to see, oh yeah, 7 is less than 4, but I can't do the block of code inside. So what I'm going to do is, if I is less than 4, I'm going to iterate through this multiple times. I'm going to write system.out.println of hello. So what do you think that will do? What that's going to do is it's going to print hello 4 times. But that's not all. Because what happens is, if I just let I equal to 0, and if I say 0 is less than 4, okay, 0 is less than 4, so I'm going to print hello. And then it's going to run through it again. Now, I is still 0. The value of I, the variable I, is still 0. So it's going to say, is 0 less than 4? Yes, we're going to print hello. Run through it again. Is 0 less than 4? Yes, we're going to print hello again. And that's going to happen infinitely many times, because 0 is always less than 4. So how do we combat that? What we need to do is we need to figure out a way to increment I. We need to figure out a way to allow it to run up against this termination, run up against less than 4. We want it to eventually not be less than 4, because then the code would run infinitely many times, and we just want it to run, 4 times. So what we're going to do is we're going to say I, and then we need to increment the value of I. And there's 3 different ways to do that. So I think the one that is programmer's favorite, the one that computer scientists like the most, is to just do I++. So you guys have heard of C++. That's just kind of a convenient way to only use 2 additional kind of characters to increment a variable. So you can write I++. If you're feeling non-algebraic, you can write I equals I plus 1. So the new value of I is just whatever the current value of I is plus 1. Or kind of a way in between is you can do plus equals 1. So that's just going to add 1 to tack on 1 to whatever the current value of I is. And what that does is, let's run through it procedurally. So if I is 0, well then 0 is less than 4, so I'll print hello, and I'll increment I by 1. So I goes from 0 to 1. 1 is less than 4, so therefore I'll print hello, and I goes from 1 to 2. 2 is less than 4, so I'll print hello, and I goes from 2 to 3. 3 is less than 4, and I'll print hello, and I goes from 3 to 4. Is 4 less than 4? No. So that's why we only print hello. If you were keeping track of what I said, you only print hello 4 times, and then 4 is not less than 4, so then the program's done. And that's all we do, is we just print hello 4 times. I gets big enough such that this code, this while loop, we're not going to run the block of code inside of this while loop anymore because 4 is not less than 4. And that is what allows us to terminate our loop. If we didn't have that in there, it would run infinitely many times, and that is not going to be helpful. So what we're going to do is we're going to click compile, and then we're going to click close, and then I'm going to show you guys what the output of this is. So we're going to click void main string args, and then I'm going to do a new share and show you guys. So here we are. So we get hello, 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 hello. And that's because when I equals 0, 0 is less than 4, so we get this hello. Then we increment the value of I from 0 to 1. 1 is less than 4, so we print this hello. Then we increment the value of I from 1 to 2. 2 is less than 4, so we print this. And 3 is less than 4, so we print this. But 4 is not less than 4, so we're done there, and the code is done. So what we're going to do is we're going to go back into the code, and so you guys can kind of take a look at that. So that's kind of cool that we can do that multiple times without writing too much code. I mean, we could make this 39 if you want, and we'll show that to you real quickly. So we'll go to looper, we'll run this program again, and we'll do new share. And so you guys can see here what we do. I don't know if you guys can see me scrolling, but I printed the word hello 39 times because I went from 0 and it just crawled up, just trickled up all the way up to 39, and then the program stopped. So that's kind of a cool thing that you can do with coding. And so loops are very, very useful. They're in almost every software program that you write, every game that you use, like the emailing app certainly has some looping in it, maybe to keep track of the emails that it's generating, and we need to complete a process multiple times, and it just doesn't make sense to write out the same thing a million times. Why not just write, while I is less than a million, do this, and then increment the value? That's a lot more efficient. It's a lot cleaner. We can also do something different with what's inside of the block of code. So let's go back to 4 just to keep it more reasonable. And I'm going to print the value of I. So what do you guys think will happen if I just say system.out.println of I? Well, instead of writing hello, 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 it's going to write 0 because when the program first starts, I is equal to 0. 0 is less than 4, so we print 0 because I equals 0. And then then I goes from 0 to 1. 1 is less than 4, so we print 1. And then I goes from 1 to 2. 2 is less than 4, so we print 2. Then we go from 2 to 3. 3 is less than 4, so print 3. Then we go from 3 to 4. 4 is not less than 4, so we're done. So what did we print? We printed 0, 1, 2, 3. And as proof to you guys that that's what actually happens, we're going to run the code again, and I'm going to do a new share. And here we are. So we get 0, 1, 2, 3, exactly what we predicted. And so that's nice that we can do different things with while loops. You can do something mathematical if you're feeling kind of interested in that. You can say, while I is less than 4, system.out.println 15 times I. And then I don't know if you guys have heard of concatenation, but what happens is if we have this plus sign, what it's going to do is it's going to concatenate this mathematical expression with a word. So we're going to say equals new number or something like that. And so what this does is it's going to take I, the value of I, it's going to multiply it by 15. So if we just had that, if we just had this, then I would equal 0. So we'd get 15 times 0 is 0. And then I equals 1. 15 times 1 is 15. And so in conclusion, it's going to print 0, 15, 30, 45. But then we're just going to concatenate the string on. So it should say 0 equals new number, 15 equals new number, 30 equals new number, and 45 equals new number. So what we're going to do is we're going to run that again. And what did we forget? Well, the problem here is that we forgot to increment the value of I. So you guys can see that we forgot that increment statement. So we have an infinite loop, and that is my fault. So what we're going to need to do is we're going to need to quit the Java virtual machine, and we're going to try this again. So what we're going to do is we're going to do I++. And so now this should work. So the class compiled as it did last time, but now we're not going to get a runtime error. So I'm going to do void main string args, 0 equals new number, 15 equals new number, 30 equals new number, and 45 equals new number. So that's just 15 times I for each of I equals 0, 1, 2, and 3. And then we just concatenate on the string new number. And so there's multiple things that you guys can do with while loops. I'll show you one more, and that is to allow the value of I to go down. So we don't have to have I going up, we can have it go down. Let's start at I equals 27. And we want to say, well, I is greater than 18. I want to print I 2 times I. So I'll just print the value, I'll just take I and I'll multiply it by 2, or rather take 2 and multiply it by I. And then, of course, I'll remember to decrement I. Why? Because I starts at 27, and we want to bring it down, 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 and keep iterating until it is no longer greater than 18. So this, we need to do a decrement. And just like for increment, there's 3 different ways to do that. So we can do I equals I minus 1, or I minus minus, or I minus equals 1. And so what should that print? Well, 2 times 27 is 54, so it prints 54. 2 times 26 is 52, so it'll print 52. 2 times 25 is 50, so it'll print 50. And it'll go all the way down to 2 times 19. So 2 times 19 is 38. So that's the last number that should show up. Why does it not run 2 times 18? Because 18 is not greater than 18. So it will not print 2 times 18. 2 times 19, which is 38, will be the last number that we print. So we're going to go ahead and run this code, and I'll share that with you guys. And indeed, that's what we get. 54, 52, 50, 48, 46, 44, 42, 40, 38. That's what we get for this block of code. So now that we're pretty familiar with while loops, just one of the most important things about while loops is we need to change the value of I somehow. We need to prevent this from being an infinite loop. So we need to change the value of I and continuously run it up against this terminating condition, because we only want the loop to run finitely many times. We do not want it to run infinitely many times. Now what we're going to do is we're going to talk about a for loop. And some students like the for loop anymore a little bit more because they don't have to explicitly remember this incrementing condition. There's no risk. There's no real risk of an infinite loop when we talk about for loops. So what we're going to do is we don't even need an external variable for while loops or for for loops. That's the other nice thing about for loops. So what we're going to do is we're going to say, okay, for int k equals 1, and I can call this counting variable anything that I want. K is less than 4, k plus plus, system.out.println of k. Now what is that going to do? What that's going to do is this just takes all of the pieces that we had in our while loop, but it puts them all together in one line. So what it's going to do is it's going to create a counting index called k, and it's going to assign this integer k to 1. Well, 1 is less than 4, so what I'm going to do at the end of the loop is I'm going to increment it by 1. I'm going to increment 1 to 2. So it'll say system.out.println of 1, and then it incremented k, it incremented 1 to 2. So it'll say system.out.println of 2. And then it'll increment it again. 3 is less than 4, so it'll print 3, system.out.println of 3. And then finally we get to k equals 4. But 4 is not less than 4, so we're not going to print k equals 4. We're only going to print 1, 2, and 3. And to test that prediction, what we're going to do is we're going to go back into the code, and I'm going to share this output with you guys, and indeed we get 1, 2, 3. So this is another type of loop that you guys can use in your programs, is a for loop. So that's a little bit different from a while loop, and we can do just another example. We're running a little bit low on time here, but what we're going to do is we're going to change it up a little bit. So what I'm going to do is I'm going to add an if statement. I'm going to add a conditional statement to this for loop. I want to check up against a certain condition. So let's say mathematically that we're interested in printing all of the even integers between 0 and 20. So what I'm going to do is I'm going to say, and we can also change the value or change the name of this variable. So I'm going to say int checker. You can call it anything that you want. Int checker equals 0. And while checker, if checker is less than or equal to 20, then instead of just changing, actually, yeah, no, that's good. So checker plus plus. So what it's going to do is checker is going to go 0, 1, 2, 3, 4, 5, all the way up to 20, and it's going to include 20. So even if checker is 20, 20 is less than or equal to 20. So that will still load, but then when we get to 21, 21 is not less than or equal to 20, so that will not print. So what we're going to do is we're going to say if k %2 equals 0, then I'm sorry, it's not k. What am I doing? I'm still living in the world 5 minutes ago. If checker %2 equals 0, system.out.println of checker. Now what does that do? What that does is it takes the value of checker, which starts out to be 0, and it says, and what do you guys know what this percent means? It means modulus. So that means that if I divide 0 by 2, do I get a remainder of 0? Well, 0 divided by 2 is 0 with remainder 0. So that's going to print. It's going to print 0 because 0 is the value of checker. What happens next? It just increments it by 1, so checker becomes 1. 1 divided by 2, well, if we think about integers and we think about the way that Java handles integers and division with integers, 1 divided by 2 is 0 with remainder 1. So this is not true. So it does not print 1. What happens if we go to 2? So checker is 2. 2 divided by 2 is 1 with remainder 0. So indeed, this is true. So we're going to print 2. And if you guys see a pattern, what's going to happen is it's going to print 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Because 20 divided by 2 is 10 remainder 0. So we do get that mod 2 is equal to 0. So what we're going to do is we're going to click compile. And I'm going to verify with you guys that this is indeed how the program is intended to run. So I'm going to do a share with you guys, and we'll get 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So we printed all of the even integers between 0 and 20 because we had that mod if statement. We said if the integer division has a remainder of 0, then print it. So 14 divided by 2 is 7, remainder 0. 18 divided by 2 is 9, remainder 0. But 19 divided by 2 is 9, remainder 1. So that does not work. So we just print the even numbers. Now I'm just going to do one more example with you guys. I know we're running short on time, but I want to think about how we can do an array, how we can use this with an array. So what we're going to do is we're going to create an array. So we're going to do int a. We're going to create an integer array equals new int of 7. Actually, let's do something a little more interesting. First of all, we need a method declaration. So I don't know what happened to that. Public static void main string args. Okay, here we go. So what I'm going to do is I'm going to say int x equals 7. Int array equals new int x. And I'm going to write this out, and then we're going to explain it concisely and then run it, and then I'll be out of time. So what we're going to do is we're going to say for int y equals 0, y is less than x, y plus plus, we're going to assign values to this array. So we're going to say system, or I'm going to say rather array of y is equal to, what do you guys want to do? Let's do 10 plus y, okay? And then what we're going to do is we're going to have another for loop down here. We're going to say int z equals 0, z is less than x, z plus plus, system.out.println of array of z. So this is a lot going on here. I know that this might be a lot for you guys, but here's what happens. Int x equals 7. Great, that's just a variable declaration. This is just an array, and what's the size of the array? It's just equal to x. So x is 7, so it's going to print an array that has 7 elements in it. So remember how arrays are indexed. It'll be the 0th element, the first, the second, the third, the fourth, the fifth, and the 6th, right? So we start at 0, and it just goes from the 0th element to the 6th element. That's just the way positions work in Java. Now this first for loop, what does this do? This assigns the yth element of the array, the name of the array is just array, and assigns the yth element of the array to whatever 10 plus y is. So what is array of 0? Well, that would be 10 plus 0, which is just 10, which means that my array is going to start with the number 10. What is array of 1? That's 10 plus 1, which is 11, so the next value is 11. And that's going to go up to array of 6. So 10 plus 6 is 16. Now what happens when y equals 7, because we increment it from 6 to 7, but if y was 7 and x is 7, 7 is not less than 7. So that means that we stop at array of 6, and we should, because otherwise we would get an indexed out of bounds exception. So what this does is going to fill the 7 elements of this brand new array, which are originally all zeros. It's going to fill those 7 elements with 10, 11, 12, 13, 14, 15, 16. Down in this for loop, we're going to just iterate through the array by printing the zth element of the array. So if z equals 0, and we're going to increment it and make sure it's less than 7. Is 0 less than 7? Good. That means that we're going to say that z is equal to 0 for the first time through the loop, and we're going to increment it at the end of this block of code. We're going to say print array of 0. Well, up here in this for loop, we assigned array of 0 to be 10 plus 0, which is 10. So it'll print 10 on one line. Now z increments from 0 to 1, so we print array of 1. Well, we assigned up here that array of 1 is 10 plus 1, which is 11. So what it's going to do is it's going to iterate through the array elements. It's going to print 10, 11, 12, 13, 14, 15, 16. And to verify that with you guys, hopefully you understand the different function of these for loops. Remember, this one just assigns elements of the array, just piece by piece. And this one prints the elements of those array, piece by piece. So what we're going to do is we're going to click close, and then we're going to run this code. We're going to click OK. And then here we go. So we get 10, 11, 12, 13, 14, 15, 16, because this is the first element of the array, the second, the third, the fourth, the fifth, the sixth, and the seventh. But remember that we're off by 1 with the array. It starts at array of 0 and it goes up to array of 6, because even though it has 7 elements, the 0th element is considered the first element, if that makes sense. So anyway, I hope that you guys enjoyed that tutorial. I hope that we worked through easy examples and then got to more involved ones. I hope that you guys understand the difference between for loops and while loops, what they can be useful for, because I did not want to print system.out.println of 10, system.out.println of 11, system.out.println of 12. Especially if you guys didn't have copy and paste available to you, that would take a few minutes to write all of that out. So this is a lot nicer. This is a lot more fun to think about for loops and the flexibility that we have with them, and also while loops. But the only thing that we have to be careful about with while loops, remember, is that we don't want infinite recursion. So we need to change that variable of I, which was our example of the variable for while loops. We need to keep incrementing it to make sure it doesn't run up against, or to make sure that it does run up against the terminating condition, so that eventually the for loop ends. It only runs a finite number of times. So thanks for listening. And again, my name is Dan Stoddard, and if you have any questions, I would love to answer them, and happy coding.